Welcome back, everybody. We are back in that 1965 Deluxe Reverb. Still have not been able to find anything wrong definitively. The bias was a little hot. So, I mean, it was hot enough that it could have explained some kind of issue going on, but that's been corrected. I played the amp for quite a while, have not been able to get it to fail in a way that matches the description I was given by the customer. But there are a couple little things we're going to go ahead and fix. Just since it's here, we're going to change the grid leak resistors, the two that are underneath these guys here. These ones were pretty far out of spec. So we're going to put some new guys in there, 1500 ohms. We're going to clean the pots, and we've got the proper fuse already installed after finding one that was over double what it should be. And we're also going to both the power tubes and the rectifier don't have the retentions. Sorry, I'll show you what I'm talking about. But these guys, the tube retainers. So we're going to throw some of these on there. It could be, my suspicion is the combination of the hot bias with the tubes not having retainers and a combo amp where power tubes take more of a beating. Maybe that's not common knowledge. I should explain that a little more. But when you have a combo amp instead of just a head sitting on top of a speaker cabinet, your tubes are much more prone to causing issues, or much more likely to cause issues if they are microphonic or in a situation where they are about to fail. Your tubes in a combo amp are going to see more vibration. And so because of that, and are basically sitting directly behind a speaker that's just beating up against them with the air and vibration hitting them. So in a combo amp, I mean, it's not to the point where like this is something you should be concerned about, but it is something to be aware of if you do have a failure that is possibly a tube, and it is in a combo amp. That can kind of explain some things of what's going on there from a technician standpoint. Okay, so we're going to start with, well, what should we do first? Maybe we'll go ahead and clean the pots first, because then when we're soldering these guys, that'll give time for things to dry out before we power back on, because we will want to double check the bias again after changing things out. Yeah, so let's dive into cleaning some pots. Okay, so just a word on cleaning pots. This may be slightly controversial, but there are two common things used here. Now, a lot of people use just generic contact cleaner, and that's fine. You don't have to use deoxit. I tend to, just because I know it's good. I don't go through it fast enough that the cost difference is that detrimental to me. And I am doing this, for other people. So I use deoxit, not for cleaning pots, unless they are really, really, really bad. They will get a squirt of this first, but deoxit is used for the D5. This is a solvent, so it is going to be destructive to the carbon tracks in a potentiometer. This is not something that you want to use on your potentiometers alone. This is for like if you have a really over-the-top scratchy pot, you would hit it with this and then use your fader lube. So tube sockets, jacks, other really corroded contacts that need a little bit of cleaning, this is what you want. This dissolves corrosion. It improves contact, protects surfaces. Great. That is not the case for carbon, which is what you have on these potentiometers. Fader F5 is specifically designed for basically flushing out and then lubricating potentiometers. And whether that's a track style, like on an actual fader, or if it's a potentiometer, this is what you want to use for your potentiometer. So, and with either one, no matter what you're doing, less is more. Always use less than you think you're going to need to, and then add more if that doesn't do it. But yeah, on your potentiometers, deoxit, fader F5. Again, kind of a controversial topic. I know there are a lot of opinions out there. Let me know if you have a better way to do it. I'm open to other ideas, but this has worked very well for me. Yeah, and then let's see if we can actually see what's going on. Here, I'll give you a closer look of where we actually apply this. Okay, we can see the backs of some of these pots here. And right in there, let's see, I'll get the actual straw. Right in here, you can see there's a space between the back shell and the front of the potentiometer. And that's where we're just going to spray the tiniest bit of our fader F5. And then we're going to wiggle the pot back and forth. This is all when the amp is powered down. You do not want to do this when the amp is powered up. And then let it sit. Sometimes if it's really bad, you'll then just give like another little squirt right back in there and let it sit to dissolve and kind of go inside. But if you spray too much, you're going to make a big mess. It's not going to help anybody out. And then after we've done all the pots, or any of them that need it, let it sit for a few minutes, let things kind of dry out before powering on the amp. So I'm going to go ahead and do that to all these pots, and then we'll move on to the next step. Okay, another thing that I like to do, especially on these older amps, is to use a burnishing tool, which is basically just some fine grit sandpaper. You could really just use sandpaper for this. And then get in between the contact points and basically just file away any corrosion that's in there. So there's a small node between those 2 points that is creating contact when there's nothing in this jack to then ground that out. And that's not such a big deal on your output here, but your input jacks on these older amps. So we have, for anything that's not plugged in, say you're plugged into this channel over here is grounding itself out and relying on those contact points, which it's going to be hard to get a view of. Oh, maybe off this guy. So it'd be, let's see, right in here, there's a little cone that's making that contact. And if that contact is not good, you're going to get that background kind of whooshing ocean sound just in the background of things when you're otherwise silent, even if you have something plugged in over here. In these older amps, they can basically lose their spring tension to create a good ground. So you either want to squeeze those together or burnish those contacts, or some combination of the two if you are hearing something like that. Okay, then to clean our input jacks, we can use our Deoxit D5, give a little spray on a jack, and just plug in and unplug a few times. Try to work any corrosion off. And then move through the rest of them. Also, while we're servicing the rest of the amp, we'll go ahead and just pull all the knobs, give every potentiometer and every jack a good tighten down, or make sure that they're tight, along with the transformer and any other points that you may have in a different amp. And then give the faceplate a wipe down when the knobs are off, just to make sure it's looking good. Okay, so the next thing we're going to do is replace the grid leak resistors, which are underneath the screen resistors. So these can be a little bit tricky just because they're buried there, and you have to work around the heater wiring. You want to be very careful when you're doing these that you don't burn other wires or other components. Okay, the new grid leak resistors are in, so now we're going to install some tube retainers on these 3 sockets, and then we'll clean all the tube sockets as well. Now to clean our tube sockets, we are going to use the Deoxit D5. Basically give a light spray, take the tube, put it in a couple times to help clear out any corrosion, and then leave it be. Now if the tubes are loose in there, that's when you have to retension the tube sockets. It probably would have been smart to do this before putting the tube retainers on, but here we are. And we'll do the same for the preamp tubes as well. Okay, we're now going to give things a chance to kind of dry. We'll go ahead and take a paper towel and wipe up any excess from the contact cleaner. And then we will come back, double check the bias, let this thing sit for a while to make sure it's nice and stable. And assuming it is, we will then plug it in and do a little sound demo for our Saturday sound check series. So we are now ready to power on to double check our work and double check the bias of the power tubes. I have the power tubes installed to the tube sockets for the CompuBias, but before we do that, whenever I'm working on the power supply, I really like to always fire up with the dim bulb tester first, just to make sure that there's no short circuits, that there's nothing I overlooked. It maybe is a extra precautious way to handle things, but I would prefer to do things this way and make sure that I didn't forget something or cause a situation where the customer's amp could get hurt. So powering on, looks like we are good. The bulb came up bright and then dimmed back down. So no short circuits in the amp. So I will just go ahead and power back down and now hook up to the CompuBias. And we are working with 6v6s, so we're looking for 7 to 10 watts on this guy. And this does accommodate for, I believe the 10 watts is at 70% dissipation of typical 6v6 tube. I'll leave this, I believe you'll be able to see this on screen. Okay, yeah, that should be good. And then also, in case we need to adjust our bias, I'm going to use my ceramic screwdriver here so that if I were to drop it into an amp, it wouldn't short circuit anything. So let's plug into full wall power here. And we are hooked up to a load via my attenuator, although it's in bypass mode right now. So we should get full volume. And I am just going to keep an eye on this to make sure that wattage, if it goes drastically above the 10 watts, I'll go ahead and shut things down. But let's see what we get. And this will show us plate voltage and idle current, which are the two things we need to know to calculate the wattage of the tube to then adjust the bias. Okay, and we did get some static there right away, which was interesting. But our bias is looking good. Just going to work out any last dust in the knobs. I don't know if you can hear that, but there's still just a little scratchiness in this reverb pot. Sounds like it's working its way out, but if not, I will hit this with a little bit more of the F5 Fender Lube. I think that's going to be good, though. If you adjust a knob and it is like crackly, staticky, just like as you're going through, that's more of an indication of DC on the pot than it is, dirt or something in there. That's like if you've ever had one of the ZVEX super hard on pedals or SHOs, they have the Crackle OK because of the way that was designed. It kind of by necessity, arguably, changes DC on the pot, which then creates crackle. But I have seen it in other amps before where something's wrong, a coupling capacitor's failed, or something along those lines. Another important note with Fender amps, the tone stack is truly reductive or subtractive, so you will get basically no signal if your tone pots are all the way down. So you always want to, when you're testing the amp, leave them around 4 or 5. Okay, so we are sitting pretty good. On our bias, which was the main thing I wanted to double check. We'll grab a guitar and just do a quick test at a lower volume. We don't want to, we can burn out the resistors and the tube sockets for the CompuBias if we play too hard or anything. So we'll just do a small test just to make sure that there's sound. So that all sounds good. No static in the pots. All good there. Okay, so I'm just going to let this guy sit for a while and make sure that the bias stays right around that 9 watts and that no other issues pop up. And then we'll pop it over to the studio side for a separate video to feature this amp as a Saturday sound check. As always, thanks for watching and hope you're having a good evening.